Good morning! Today we're going to try to answer the following question. How to measure the force of a fan. And so for starters, we're going to try doing a direct measurement. We have an electronic balance. We have a tray. And the goal of the tray is to try to catch the air from the fan. The size of the tray has been selected so that it's slightly larger than the diameter of the fan blade. The balance has been zeroed such that the mass that we will record in a moment is only due to the fan pushing the air directly on the tray. Once we have that mass as registered by the electronic balance, we'll multiply by 9.8 and that will give us the force. So here's our first attempt. Let's see. So in our first attempt, it seemed that our results were somewhere between 41 grams to around 45 grams. Let's try again. Attempt 2. For attempt 2, you'll notice that the scale went slightly above 50 grams. When that happened, I accidentally hit the cart into the tray. And so we're going to ignore that result because that was a result of me hitting the fan cart into the tray. So if we ignore that, then roughly we have a range of somewhere between 46 to 49 grams. Let's try one more time. For this particular trial, I believe the range was roughly somewhere between 42 grams to around 48 grams. And again, there was a brief moment where the scale registered a mass greater than 50, and whenever that happened, it was because the cart physically hit the actual tray. Now, if I was to do this experiment again, instead of holding the cart in my hand, I would probably try to use some sort of retort stand with some sort of handle to actually hold the fan cart. One of the problems though was that I didn't have the appropriate equipment to complete that task, and so I ended up holding it in my hand. But again, I should have probably had a retort stand with some sort of handle. I didn't have the handle, but I had the retort stand. So that's one improvement we can make in this experiment. Nevertheless, here's a summary of the 3 different attempts in terms of the range. So the average mass is roughly 45 grams, give or take 4 grams. During this experiment, I was trying to move the fan cart up and down to try to get the best results. By best results, I mean most consistent results. With the mass that we have, we multiply by 9.8, and we end up getting a result of 440, give or take 40 millinewtons. Because we've left the mass in grams, the unit is not the newton, but the millinewton. So we're going to try a second method based on kinematics and Newton's second law. The reason why we're doing this is because we're not 100% sure if the first method is accurate, especially because it was highly variable. So here's what the experiment looks like. From this video, we're going to ultimately determine the acceleration. We'll have to measure the mass of the fan cart, and we'll calculate the net force. So looking at the forces, we have the force of the fan pushing the cart forward, and we have the force of friction holding the cart back. Net force will be equal to fan force subtract friction. Or, rearranging this equation, to get the fan force, it's net force plus friction. So we're going to need to measure the net force, and we'll also need to measure friction. All right, let's see how we measure net force. To do that, I'm going to ask you to complete this table. Here are the calculations for that table. For the first equation, I want you to notice that I'm asking you to divide by a factor of 4 to get the average time. Why is that? Well, because the video is recorded in slow motion, and slow motion increases time by a factor of 4. Now I want to focus our attention on the second equation and discuss some of the assumptions we've made. The first assumption is that we're assuming constant acceleration for 50 centimeters. This assumption has been confirmed with motion tracking equipment I used prior to the experiment. Secondly, the initial velocity has to be 0 in order to use that equation. All right, you're going to start your stopwatch the moment you see my fingers begin to move. You're going to stop the stopwatch when the cart has passed the 50 centimeter mark. Really try to focus on avoiding anticipation. In other words, you really have to focus on stopping the stopwatch when that cart hits the 50 centimeter mark. This is very challenging to do. I've seen people quite often stop the stopwatch prior to the cart hitting the 50 centimeter mark. So try to avoid anticipation. All right, get ready. Here we go. So hopefully you've gone back to the video. You've recorded 3 different times for slow motion trial times. You've done all your calculations and you've gotten the acceleration. So now we have to get net force. Well, to get net force, we need the mass. This is the mass of the fan cart. Please pause video now to determine net force. All right, net force is of course mass times acceleration. That's Newton's second law. And so you have your net force. But we don't have friction. So we're going to have to do another experiment. And this is what the other experiment looks like in real time. However, we record this in slow motion as well. While coasting to a stop, the only force really acting on this cart is friction or mechanical resistance. I have a question for you. Why is drag not considered? Why is it not a factor? So here's our net force statement. Notice there's a negative in front of the friction. This is because friction slows objects down. And of course, net force is mass times acceleration. And so this is the equation we're going to use to determine friction. Clearly we need mass and acceleration. So here's a table I'd like you to complete. This time we just don't have one run, we have 5 different videos to analyze. Video A, B, C, D, and E. Here are the equations you'll be using for this table. They're very similar to the previous table. Except, please notice there's a negative there. That negative is there because this time the object is not speeding up, the cart is slowing down. To use this equation, please note that we have to assume the final velocity is 0. So you're going to start your stopwatch when you see the cart pass the 0 of the meter stick, and you're going to stop the stopwatch when the cart has come to rest. Get your stopwatch ready. Here is run A. Here is run B. Here is run C. Here is run D. Here is run E. So hopefully you've recorded all the displacements, you've got your slow motion trial times, and you've ultimately determined acceleration. Knowing the mass and the acceleration, we can determine the force of friction. So now that we have the net force and we have the force due to friction, we can determine the fan force. So now it's time to compare. Our direct measurement was around 440 milliunits. When you did the experiment and analyzed using second law in kinematics, you probably got a fan force that's similar to that result, but yet they don't really agree. And so the question is, which method is more accurate? Well, in your report, I want you to discuss that. And in addition, I want you to discuss what possible modifications you can make for either approach to make the results more accurate. I hope you enjoyed today's activity. Have a great day. Bye-bye.